So 2 new vocabulary terms for you today. The first is an angle of depression. This is the one where I see the most mistakes. We'll talk about that in a second. And then angle of elevation. So if you have a word problem, then you'll hear these words come up. Are you done your bag? Your headphones out. Put your back toward this. These always come from a horizontal line. So your angle of elevation typically comes from, and it's called elevation because you're going up. This is typically like the ground or something like that, but it has to come from a flat line and then goes up. So this right here, notice how they're marked the same? It's because they're congruent. What kind of angles are these? Or angle pair, I should say. They are alternate interior angles. Since you have right angles here, these are parallel, and you have alternate interior. Awesome. You're back. And then we also have angle of depression. This line at the top that you see is typically a couple of things. It could be a line of sight. So like say someone is standing in the Statue of Liberty and they're looking out. That would be their line of sight. It could be a plane, something flying horizontally, like a bird or a plane. That's usually the most common ones that you see. The angle of depression has to come from that horizontal line down. It's a sad way to think about it, but depression means that you're feeling down, and so it has to, from the top, down. The most common mistake that I see, and I see it like a million times every single year, I'll tell you that the angle of depression, for instance, is 40 degrees. And every single year I have a handful of students who go, oh, 40 degrees. No, that is not any kind of angle. Oh, it's an angle, but it's not the angle of depression. It's not the angle of elevation. It's nothing. Your angle of depression has to come from a horizontal line down. It is not this angle right here, which is the most common mistake I see. On these word problems, if you don't have a picture, you should draw one, obviously. We're just going to get started with them. And you'll probably make some mistakes along the way, and that's okay. We'll learn from it. This first one, you have a picture. It says the angle of elevation, so that would be going from like the ground up, the bottom up. From the swimmer to the lifeguard is 35 degrees. Find the distance x from the swimmer to the base of the lifeguard chair. I know it's kind of labeled poorly on yours. Here's your angle of elevation, 35 degrees. You know that the lifeguard chair, at least up to the guy's eyes, is 6 feet. And you're finding, it says find to the base. Please remember that the base is the bottom. So the base is the bottom of the chair. Typically, if I ask you to find the distance to something, I am talking about on the ground. Because when we measure distance to stuff, we don't measure to the top of it. We measure to where we can actually measure it, on the bottom of the ground. Okay, at this point, you solve it the exact same way you've been solving it for days now. Right? I want to see new triangle equals reference triangle. If you want to do this without me, that's fine. You go for it. I'm going to do it on the board. But you have your trig sheet with you, so you can use it. I trust you to do that. You have 6 and x. That would be your opposite and your adjacent. We're not solving for y. Okay, go for it. Solve this one out, please. I should see these steps. Remember we talked about, for now, you're not taking a shortcut. Later, I'll let you take shortcuts. But at this point in time in our unit, I need you to show all the steps. Why is it again that these ratios are equal to one another? Why am I allowed to do that? Why do we have ratios that are equal? Do you remember? There's one One big reason. What is it? Sam, you remember? They're similar. Good. The same angles. So the similar triangles have the same ratios within them. I don't know what this is. Tangent of 35. Anybody have that? 0.7002. Okay. Then you need to cross multiply and solve. If you used A over O, then you would be using cotangent, COT. Regardless, you're going to end up getting about 8.568. I'm going to round that to the 10th. So it's approximately 8.6 feet. Do we agree? And remember, you can check your work. 35 degrees should be across from the shorter side. Since the other angle is going to be 55, this side should be longer. Okay, we only have really one more example. So that's your angle of elevation from the ground up. That one is, I usually don't really see mistakes on. Angle of depression is where we see some issues. This one you now have a picture, so you should draw one to the best of your ability. The more detailed it is, usually the easier it is for you to understand. This is a weird one. It says a camera attached to a kite, maybe it's like a GoPro, all right, is filming the damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. So we have some kind of, I'm going to literally call it closed-off area. And someone finds this interesting. And so they are flying a kite directly above it, above the center of it. Let's see. They've got this kite. And they have put this little camera on top of it. We're just going to call that the camera, okay? And here's their little string. Okay. A person is standing 100 feet away from the center of the closed-off area. So you have this dude over here, or lady, I guess, and they're flying this kite. It says the angle, let's label this. So 100 feet from the center. So from the person to the center of the closed-off area is 100 feet. It says the angle of depression from the camera to the person flying the kite is 25 degrees. So you have, here's the camera's like line of sight basically, right? That horizontal line. From the horizontal line down to the kite string, you have the angle of depression right here. Okay, now we just talked about how the angle of elevation, angle of depression are the same because they're alternate interior angles. So you also can take that 25 degrees and label it here. Just because that's a little bit easier to work with, it's right next to the 100 now. How long is the string of the kite? So you are finding the hypotenuse. We're going to ignore the slack in the kite string, assuming that it's like pulled tight. I need you to solve. So you have a right triangle. Your right angle will be in this bottom corner. You have your hypotenuse and your adjacent. You can go ahead and start solving. I will do it on the board, but if you want to do it yourself, please go for it. I'm going to do h over a. Oop. Which would be secant. So x over 100. So I should either see you follow along with me on the board, or I should see you solving this one out on your own. Ben, what do you got for secant? 1.103? After you cross multiply and solve, you'll get that it's about 110.3. Oh, amazing. Just want to switch. A quick way to check your work. You know that it should be, so this is a hypotenuse, it should be the longest side, at least it should be longer than the other one that you have. It is, so that's a good way to check your work quickly. The only difference between this and the next one is that on the next one, it's telling you that the string of the kite's 200 feet, and then I'm asking how far away must the person be. So you have the same kind of triangle. You got the kite, you got the string, the person right here, but we don't know how far it's going to stand. That person's going to stand. We do know that the kite string is going to be 200. And that the angle of depression is the same. And so you can go ahead and label, since the angle of depression is up here, angle of elevation is the same. So this is still 25 degrees. And again, this one up here is also 25 degrees. I need you to solve, this would be solving for the adjacent side. Go ahead and solve that one whenever you're done. Summarize. And you're good.